Scientists have created shape-shifting 4D printed objects that dramatically transform when heated. The objects are made from shape memory plastics created using a 3D printer, but are labeled as 4D printed because they can change their shape after production. The researchers say that the morphing materials could be used for super lightweight structures needed for space exploration, or even shape-change soft robots. They could also be used to save room on future space missions to Mars, for instance, by having large pieces of equipment fold out from a smaller initial shape to create homes on the planet. We believe that you could build something like an antenna that initially is compressed and takes up little space, but once it's heated, say just from the heat of the sun, would fully expand, study co-author Professor Jerry Key said. The new objects use tensegrity, a structural system of compressed floating rods, known as struts, and cables in continuous tension. The researchers, from the Georgia Institute of Technology, made the struts from shape memory plastics that unfold when heated. Tensegrity structures are extremely lightweight, while also being very strong, study co-author Professor Glaucio Paulino said. That's the reason there's a heavy amount of interest right now in researching the use of tensegrity structures for outer space exploration. The goal is to find a way to deploy a large object that initially takes up little space. The researchers use 3D printers to create the struts that make up one of the primary components of the tensegrity structure. The researchers designed them to be hollow with a narrow opening that runs the length of the tube so that they can be temporarily folded flat. Each strut had an attachment point on each end to connect to a network of elastic cables, which were also made with 3D printers. Once the struts were heated to 65 degrees Celsius, the researchers could partially flatten and fold them into a shape resembling the letter W. When cooled, the structures permanently retain the temporary shape. A key goal of making 3D printed objects that can transform into tensegrity structures was accurately controlling the rate and order of expansion. The shape memory polymers enabled the researchers to fine-tune how quickly each strut expanded, by adjusting at which temperature the expansion occurred. That enabled structures to be designed with struts that expand sequentially. For bigger and more complicated structures, if you don't control the sequence that these struts expand, it tangles and you have a mess, Professor Paulino said. By controlling the temperature at which each strut expands, we can have a phased deployment and avoid this entanglement.